Hey guys, in this video you're going to learn how to make the Lewis structures, not Lewis dot diagrams based on valence electrons, but Lewis structures. So when you're given a chemical formula, whether it's ionic or covalent, you are going to be able to write the structure with the appropriate number of bonds and the electrons that are left over. So we're going to go over how to do that. Okay, so for the Lewis structures, there's this sheet that I gave y'all to do, and it might look kind of confusing, but hopefully not. I want to point out a couple of things. Okay, if you were to try to watch this on YouTube from some other professor or teacher, you're going to notice that they're going to get you to count up the total number of valence electrons and then try to get a certain amount, and it's really confusing. You're going to get the same answer if you just follow the instructions I give you. It's really not as confusing as they make it out to be. So there's a lot of different steps that are involved in this practice sheet, and I don't want you to have to stress yourself over all of that, okay? So for HCl, that's a almost ionic compound. So it's a really superpolar covalent compound. So first I'm going to go back to the ionic compounds, okay? So for an ionic compound such as sodium chloride, okay, you have the sodium atom, and I asked you guys to do this on the practice sheet. Sodium atom, how many valence electrons? There's one, okay? The chloride, the chloride is going to have 1, 2, 3, 4, 5, 6, 7 valence electrons, okay? And anywhere that you see a single dot, that's where one bond can form. So we can actually form a bond between sodium and chlorine. Looks like I did not have this connected. So between sodium and chlorine, if I were to take this little dot and move it to this side, now sodium and chlorine can both bond to each other with their little single connection, okay? So I can take this and make a bond between sodium and chlorine, and notice that sodium would then, if it gives its valence electron up, and they mutually, well, they're not mutually sharing, are they? Because it's ionic. But if sodium gives its electron to chlorine, chlorine would then have 8 electrons, and then sodium's inner shell would have 8 electrons. But where these two electrons kind of meet up, that's where you have a bond. Okay, so if I were to represent this with a Lewis structure, I would draw a sodium and then one bond to chlorine, because they're each contributing 1 electron in this bond, okay? And then the chlorine is going to have 1, 2, 3, 4, 5, 6 dots left over, okay? What just happened? Let's try this again. So chlorine has 6 dots left over. Well, for ionic compounds, we don't typically write all of that. For an ionic compound, we would just write it like NaCl, and we're done, okay? For something like, let's try magnesium chloride. So magnesium chloride is MgCl2. You have 1 magnesium and 2 chlorines. You would put the metal in the middle, okay? So what in the world? Magnesium is going to bond with chlorine, and so you have a magnesium with a chlorine on either side, okay? And that's pretty much it for your representation of magnesium chloride. I'm just going to scoot it over a little bit, okay? So that's pretty self-explanatory. Everything is just a single bond, and everything's pretty decent there, okay? But let's move on. Let's move on to the covalent compounds, because that's where it gets a little more complicated, okay? So for covalent compounds, I have this in this looks really hard for you to read. I have this in a practice sheet, okay? Not this practice sheet. So I want you to ignore all of this, but for the covalent compounds, just like HCl, you're going to have a different set of rules for writing this than all of these steps. I feel like that's, like I said, way too complicated. So we're going to follow these steps, and the first thing we're going to do is draw a Lewis dot structure. That's including your valence electrons. okay? And then we're going to rearrange the atoms so that the one with the highest number of valence electrons, that's going to be your central atom, the one that goes in the middle. If that's even an issue. If it's one of each, then we don't have to worry about that. So what we're going to do, we're going to start out with, let's do carbon dioxide, okay? So carbon dioxide, we're going to do the Lewis dot structure for each one. So how many valence electrons does carbon have? Well, it has 4 valence electrons, okay? And then we have oxygen. Each oxygen has how many valence electrons? 6, okay? So 6 valence electrons for the oxygens. Carbon has 4. So I told you that each single dot is how many bonds that element forms. So, of course, I need to move so you can see this. So, how many bonds does carbon make? Carbon will make 4 bonds, okay? So it can make 4 bonds. Each oxygen makes how many bonds? Look at the single dots. 1, 2, 1, 2. So oxygen makes 2 bonds. So I want you to notice something about that. The next step is to rearrange the atoms so that the one that forms the most bonds is going to go in the middle. So here's what we do. Which one makes the most bonds? Carbon. So carbon is going to go in the middle, okay? And let's see if this will work. It'd be great if it does. If carbon goes in the middle, and each oxygen then is going to go on either side of carbon. Of course, that one doesn't want to work, so let's make an oxygen here and an oxygen here. Oxygen has 6 valence electrons, okay? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if I have 6 valence electrons on each oxygen, oxygen can make 2 bonds, carbon can make 4. Let's try to figure out an arrangement so that we will satisfy the number of bonds each one wants to form, and then figure it out from there. So carbon can make 4 bonds, okay? So carbon makes 4 bonds, and we can only bond to 2 different things. If we kind of split that up and do it evenly, well then carbon is going to form 2 bonds to each oxygen, okay? It's going to make a bond with oxygen, but it's going to be a double bond, 2 bonds to each oxygen. So if we do that, let me erase this, okay, then we're going to have a double bond. So let's just see so far, based on the number of bonds, if we satisfy these requirements. Does carbon form 4 bonds? 1, 2, 3, 4. Yep. Does each oxygen make 2 bonds? 1, 2, 1, 2. Yep. So now we have to determine the number of dots or electrons left over. So to determine that, we are going to do a subtraction, okay? And we're going to take so to figure out the number of dots left over, or the number of electron dots left, we're going to take the number of valence electrons minus the number of bonds. This is for each atom. That's going to tell us how many dots we have left over. So carbon has, let's draw this again, carbon has 4 valence electrons. Well, it makes 4 bonds. So that's going to be 4 valence electrons minus 4 bonds. Carbon has 0 dots left over. Okay, and by the way, our dots are, for honors chemistry, for the lesson that we're learning right now, you're just going to have an even number of dots left over. Okay, so they'll always be paired up. So let's look at oxygen. Oxygen has 6 valence electrons. Each oxygen forms 2 bonds. So that's going to be how many dots left over? 4. So each oxygen is going to have 4 dots left over. And for these, you can space them out. so that they're evenly spaced. Okay, so 1, 2, 3, 4, and then that's not really pretty, so I'm going to redo that one. This is going to be 1, 2, 3, 4. So our Lewis structure for carbon dioxide is right here. Okay, carbon dioxide has a carbon with 2 bonds on each side. Those are both bound to oxygen, and then each oxygen has 4 electrons left over. Okay, does that make sense? Let's maybe do another example. So let's try, let me just scroll down. So let's try something like, this is going to look really complicated, but it's not that bad. Let's try PCl5. Okay, so phosphorus. All right, we've got phosphorus, we have chlorine, so let's look at the number of valence electrons. Phosphorus has how many? Remember, you need to use the periodic table, look at your group numbers, or count the number of squares to figure out the number of valence electrons. Phosphorus has 5 valence electrons. 1, 2, 3, 4, 5. How many bonds can it form? Well, it's got 3 single dots, so it can make 3 bonds. Okay. Chlorine has Cl, and then you've got, for chlorine, you've got 7 valence electrons, and then they can make, let's see, 5, 6, 7. Chlorine can make how many bonds? Just 1. Okay, and then we've got 5 of those. So, but you put the one with the most number of bonds in the middle. So if you have a phosphorus in the middle, how's this going to work? Well, now I get to tell you that any element from period 3 can actually form the same number of bonds as its valence electrons. It's called an expanded octet. So that's not something that we're really going to test over, but something that you just need to kind of keep in mind. If you take AP Chemistry, or if you wind up taking chemistry in college, that's going to be something really important for you to know. So let's draw PCl5. So it can form up to 5 bonds. In this case, phosphorus will. So you have a phosphorus bound to 5 chlorines. Okay, we're going to make it kind of look like a star. All right, so if phosphorus has 5 valence electrons, okay, and it makes 5 bonds, how many dots are left over? 0. Okay, so phosphorus looks like this. Now each chlorine, we have to take it case by case. Each chlorine has 7 valence electrons. We're going to subtract the number of bonds. Chlorine's just going to make 1. So you're going to have 6 dots left on each chlorine. So let me do this in red so it'll kind of stand out. So 1, 2, 3, 4, 5, 6 on all the chlorines. Okay, so draw that in. Do not know why it's trying to do that. Maybe I'm trying to do this too fast. I think so. So we just got to take our sweet time. So I'll talk to you. What in the world? I'll talk to you while we're doing this. So the main thing that I want you to get from this part of the unit is drawing the structures, figuring out how many dots are left over and how many bonds something forms. And by the way, you can look at the number of single dot electrons, or you can actually look at the charge. So the charge of the element, if it were ionic, which these aren't, is also going to represent the number of bonds that these elements can form. Just keep in mind, now this one's a little bit more advanced than what your practice work is, but the number of bonds that form can also equal the number of valence electrons for your third period, third energy level elements, okay? But that's all there is to it. I just want you to try the practice problems and then we'll go over them in class, all right?